You're crouched in tall grass, savanna floor still warm under bare feet, roughly 100,000 years ago. Something moves 2 feet to your left, low, fast, gone before you can name it. You don't scream, you don't even breathe. Every muscle in your body has already decided to freeze, a full half-second before your conscious mind catches up and tells you why. Snake. Right now, you could go your entire life without ever standing that close to a venomous one. Most people alive today never will. So how did the humans who came before you, no antivenom, no hospitals, no ambulance, survive sharing every stretch of ground with an animal built to kill them in under an hour? Start with the obvious answer, and then throw it out. Ancient humans didn't survive venomous snakes by becoming immune to them. Almost no primate did. In 2006, anthropologist Lynn Isbell at the University of California, Davis, published a theory that rewrote the story of primate vision. She argued that snakes, not leopards, not eagles, were the predator that mattered most, because snakes had already been ambushing early mammals for something like 60 million years. Primates living alongside venomous snakes, her data showed, evolved sharper close-range vision and faster threat detection than primates on snake-free islands. The lemurs of Madagascar, isolated from snakes for millions of years, still lag behind. Translate that into plain terms. The reason you can spot a coiled shape in leaf litter before you consciously register what you're looking at isn't an accident. It's inherited dread, built one generation at a time, long before a human ever stood upright. So if your ancestors never evolved venom-proof blood, what did they evolve instead? Everyone assumes there's a version of humans out there somewhere with venom-resistant genes, the way honey badgers supposedly have. The truth is stranger. Several animals really did evolve that trick. Humans just weren't one of them. In 2015, biologist Danielle Drebeck published a study in the journal Toxicon comparing the venom receptor genes of honey badgers, mongooses, hedgehogs, and, improbably, wild pigs. 4 completely unrelated species had each independently landed on the identical fix, swapping one amino acid in the exact muscle receptor that snake neurotoxins are built to latch onto. Same mutation, same position on the gene. 4 separate times by 4 animals that never shared an ancestor with that trait. It's one of the cleanest cases of convergent evolution on record. Your version of that receptor never changed. It's sitting in your muscle cells right now, exactly as exposed as it was 100,000 years ago. Here's a second animal that beat the snakes at their own chemistry, and it isn't close. In the mid-1970s, researchers at the Edgewood Arsenal Biomedical Laboratory in Maryland found that the North American opossum could take a full lethal dose of rattlesnake venom straight into its bloodstream and just keep walking. 2 decades later, the protein behind it was isolated and named the lethal toxin neutralizing factor, a 63,000 Dalton molecule that behaves like a built-in antivenom factory, riding around in the opossum's own blood. One animal, one protein, resistance to nearly every major snake family on Earth. You have nothing like it. Not a trace. So without the mutation, and without a built-in antidote, how did anyone survive long enough to pass anything down at all? Everyone assumes immunity to poison has to come from your genes. The truth is at least one ancient human tried to manufacture it by hand, on purpose, 1 dose at a time. Mithridates VI, king of Pontus in the 1st century BCE, is said to have spent years dosing himself with small, escalating amounts of poison, terrified, according to the accounts that survive him, of dying the way his own father may have. Historians still argue over how much of the story is legend. But the underlying idea, small doses, repeated exposure, deliberate risk, was taken seriously enough that his name eventually became the word for it. Mithridatism. 2,000 years before anyone understood what an antibody was, someone had already guessed the rough shape of the answer. The species-wide version of that guess didn't come from a king, though. It came from ordinary people who never stopped doing the work. In 1978, herpetologist Romulus Whitaker helped organize the Irula, an indigenous community in Tamil Nadu, into a cooperative built entirely around catching venomous snakes by hand. They still go out in teams of 4 or 5, never alone, carrying short iron hooks and a set of techniques taught by parents who learned it from theirs. Decades later, that cooperative supplies most of the raw venom used to manufacture antivenom for the whole of India. No mutation did that. No serum protein did that. A rule, never hunt alone, repeated for generations, did. So what was actually protecting people, in the end? Here's the real answer, sitting underneath the obvious one. Ancient humans didn't out-evolve the snake. They out-cooperated it. Every genetic shortcut on this list, the badger's receptor, the opossum's protein, evolution handed to some other species and quietly withheld from yours. What you got instead was slower and messier, and it worked anyway. knowledge that outlived the person who learned it. That project isn't finished either. In 2025, a research team led by Jacob Glanville at the biotech company Centavax, working with immunologist Peter Kwong at Columbia, published a study in the journal Cell built around a single man. Tim Friede had spent nearly 2 decades injecting himself with escalating snake venom doses, over 700 injections, more than 200 bites, entirely on purpose. When the team screened his blood, they found antibodies capable of neutralizing venom from 13 of 19 of the deadliest snake species on Earth in lab trials. One human being, using nothing but repetition and risk, built something closer to the honey badger's mutation than 300,000 years of Homo sapiens evolution ever managed on its own. So go back to that half second in the grass, before your mind catches up to your body. That freeze isn't luck. It's 60 million years of ancestors who got it wrong, quietly edited out of the gene pool, one bite at a time. You were never going to get the mutation. Almost nobody did, except a handful of unrelated animals evolution happened to favor. What you got instead was a species willing to stand in that grass together, pass the warning down, and, eventually, inject the venom on purpose, just to prove it could be. The snake never lost a single drop of its venom. Humans just stopped having to face it alone. You're frozen in tall grass, 100,000 years ago, a shape moving through the leaves before your conscious mind even knows what it's looking at. That reflex is older than language, and it's the beginning of one of the strangest survival stories in human evolution.